President Matt Timmins with Timberwolf up here at our Syracuse machine shop. Just thought I'd take some time today and make a video, kind of show you guys what it is that we actually do at Timberwolf and what makes us stand out from our competition. So it's March 18th of 2023, day after St. Patrick's Day. Actually getting some snow here in upstate New York. Look out the window there, she's coming down. It's pretty nice. So Timberwolf, we got about 50 guys working for us. We make somewhere in the realms of 1,000 machines a year between our Pro HD firewood processor all the way down to our TW2 firewood splitter. We're pretty different than a lot of our competitors. We make a lot of our own components ourselves, hydraulic cylinders, valves, manifold blocks, even getting into some hydraulic pumps and motors, and then obviously all the frame components and stuff. We feel that by doing that, first off, we're learning a hell of a lot about the manufacturing process, and we also have ability to control the quality and design parts that really fit our machine's needs better than relying on outside vendors, and of course lead times and supply chain issues kind of insulates us from it. So it was a big risk we took a couple years back to do it, and there's definitely been some bumps on the road, but we're really getting getting the hang of this high precision machining and making some pretty good parts and designing some good parts for our machines. So that's what we do up here. This is one of the 3 buildings we have. After the parts leave here, they head down to Marathon, which is about an hour south of here. We're in Syracuse right now, and over there we weld everything up and we paint them and we assemble them ready to hit the road and get on to the customer. One day here soon we'll do a video of that facility as well. So yeah, just gonna give you guys a tour of what we got going on up here. All right, here we are in the design office at our Syracuse facility. We got a couple of fancy computers here. You can tell by the lights, they got to be pretty powerful. And we run Solid Edge. It's 3D design software. Also integrates with our CAM to program our machines, tell them what to do. And then, so all the designs come out of here and they get sent out to the shop, which is right through this door here. So this is our machine shop. We've got 5 CNC machines in here, a big Doosan, a big Haas vertical, small Haas vertical, and then 2 Haas lathes. So these machines produce about 380 different parts every week. A couple examples we're working on right now. Here's some sprockets that are in process. We've got 1 op, 2nd op, and then your finished product right there. Now a lot of guys, they're going to buy these sprockets from Martin or something, but this saves us a little bit of money, and it also allows us to build them exactly the way we want for our machine. After this, they'll get heat treated. That's all done in this vertical machining center. I'll turn it off right now so I can't open the door, but inside there you can see a sprocket. Over here, this is a TM1P. It's an old, reliable machine, works pretty good. We're making wedges right here. You can see here, this is a wedge for our 4-way wedge on our Alpha. And it's a 1/2 inch thick AR plate. And it's got a 45-degree knife edge in it. Pretty fine. We go for about a 1/16 inch on the edge there so it doesn't fold over on splitting the wood. And that starts out, comes off our burn table, it looks like that. So what we do, we put that in the machine here, 4 at a time. You can see this face cutter here, 2-inch face cutter with replaceable carbide inserts. Comes around and makes a racetrack pattern. Actually, it's traveling in this direction. And it makes a wedges. So you got 4 in there, and then we flip them over and do the other side. To do the 4 wedges, it's about a 35-minute process in here. I think it works out pretty good. We make lots of different wedges too, bigger, smaller. That's just one of what we do. Over here, the ST10. This is a CNC lathe. Right now we're making a fairly simple part. This is a ring that we burn off our burn table at a 1-inch material, and we're actually making the bushing for the pullback arm in the Alpha. So in the first operation, the lathe's grabbing it like that in the chuck. We're boring out a very smooth, perfect 1 3/4 center, and then we're making a 2-inch OD I'm sorry, 2.5 inch OD on the outside. Then we're going to put it in the chuck. This whole stack's done first operation. We're going to flip it around, grab it like this, and then finish that to a 1 3/4 OD. And that's all happening in here. Get a little bit of action in the window, ignore that, in the chuck here, using this boring bar. Then over here, this is our big, pretty cool machine. It's a Boss VC400. It's got a turntable on it. So how this works, this rotates 180 degrees around. So we'll take our raw material, which is actually a finished part, and we'll place it into the vise right here. Tighten it up, obviously with a vise wrench, which is on the other side. Close the door, hit that button. That tells the machine the next part's ready to go. So while you're operating there, the machine's actually working here, so it hardly ever stops. And you can see here, we've got our indicator in there, so that's positioning the part, and it's getting ready to make a part. Right now, it's operating in single mode, not actually using the other side. So that's, I think we're making a new experimental saw box there. So this machine makes a lot of parts. Here's an example. These are our dump valves. First up, just a piece of aluminum, gets face down drilled, and then when it's all said and done, it's all squared up, tapped, ported with a T2A sun cavity. That's for a dump valve to go in there. Actually, it's a check valve. We call it a dump valve. That's what it does for us. And you got two number 12 ports, top and bottom. That allows fluid to come out of the cylinder faster. So we're making those parts here, and that's one of the many parts this machine makes. Over here we got a big lathe. It's an ST30L. Does up to 60-inch long parts, 3-inch through spindle, 30 horsepower motor. Pretty big machine. Mostly making cylinder components on this machine here. Open this door up here. So we've got our steady rest in there. This is a 3.5-inch chrome rod. And what we're doing here is we've turned that down. We're going to cross drill it with this live tool we have in here with an 1.25 inch pin, and that will make our cylinder rod for Alpha and our Pro HD lineup. We also make our bodies in there. Here's a couple of them that are in various stages of completion, and yeah, it's a pretty nice machine. So we're going to come over here. This is our tooling room. So those bushings I was talking about earlier, there's a finished bushing right there, ready to go. Nice surface finish on the inside. Slips right in the tube. Then our pullback arm rests right in there. It allows it to float up and down with the wedge. Just one example of parts we make. This is inventory for some of our burn table material. And then we have our cylinder inventory here. So this shelf here, all the components go into the different cylinders we make. Right now we're making 4 inches. 4 inches and 5 inches. The 4 inches are for the faster cycle time, a little less power. The 5 inches get a little more power, but they're a little slower because you're displacing more fluid. So you can see the various components here. This is a 4-inch piston. So this started life as a solid block, a 1045 steel. We've gone ahead and we've machined it down to a very precise diameter. You've got the slots for your wear rings, and then your T-seal, which actually holds the pressure, and this moves up and down the body of the cylinder. And then here you've got your through hole. This will actually get bolted on to the end of the rod. The rod will sit right in there. I think it's a 1-inch bolt, gets tightened on right there. So that's your 4-inch cylinder. This is the gland for the 4-inch cylinder. This one's got seals in it already. So this again started life as a solid 4-inch block, actually slightly over 4. I think we come in at 4 1/4. We bore it out, we machine it to a perfect 3.980 OD. We put this O-ring seal at the backup ring. It slips into the machine like this, and that's actually holding your pressure in. And then you've got your two, so you got a full 1-inch thick wearing surface for your wipers, and then your rod seal, and then your head seal. This just keeps debris out of the inside of the cylinder. So that's sitting in there, all manufactured right here. And on this side, you have the same thing, just a little bigger. This is our 5-inch cylinder material. 5-inch OD. This is the piston. All operates in the same fashion. And this is the gland. Then what we have here, you can see the different drawings. So we can identify, we have all of our tolerances for measurement. Everything gets 100% inspection in here. It's got to land between these tolerances. And we'll be filling out these inspection sheets, and then that gets serialized so we can track any problems through the process. So, we're trying to be as professional as possible with what we have. Some other parts over here, we got all of our wear rings. We get our wear rings and our seals from a company down in Florida called Hercules Sealing Products. They're real good to work with, pretty knowledgeable staff, and real good on inventory. Comes out of America. Then we have some other components. These are some bungs. This is a number 16 bung. So our cylinders have big holes in it. True 1-inch hole in the center there. Lets our get a lot of flow out of that cylinder with minimal heat. So we're making those all in house. This goes on that ST10 lathe. Starts at a solid 1 3/4 bar, and that's the finished product there. Cross tubes, dowel pins, and then overflow inventory for seals. So a lot of stuff going on there. Quality control. That's what we do in this area. You can see our measuring devices here. Pretty accurate, perfectly smooth granite slab. And then we have an indicator to measure heights and such. And we also use a lot of calipers. You can see the different drawings on the wall for the assemblies of the cylinders. Those are all the different cylinders we make right there. So after we get out of the inventory room, got some more pistons here. A couple of tools we're using to check. One of these days we're probably going to get a CMM, but we got some internal groove calipers, and try to be as careful as possible with these. And then these are some large diameter calipers. And then we're also using micrometers, which are locked up in that toolbox because they're real fragile. We've got our test bench over here. So every cylinder is tested up to 5,000 PSI. Just make sure all the seals are good. We got a valve, we got a flow meter, the pressure gauge right there. You can see 5,000 on it. And this whole thing is actually powered by a 50 kilowatt electric motor, 460 volt 3-phase. And behind there it's hooked up to a pump with a pulley. And that pulley is simulating 2,400 RPMs. Out of the 1,800 RPM electric motor. And then we've got actually one of our Pro HD hydraulic tanks up here. Holds 70 gallons of fluid because every cylinder takes about 3 gallons. So you do 10 cylinders a day, you need 30 gallons of oil right there just to fill the cylinders on test. So we're filling that up quite often. And it's a little crude, but we're trying to improve on it. Eventually we're going to have multiple valve banks here and a nice control panel over this. This is our cylinder assembly table. So cylinder gets laid down up here. We've got a little hoist so guys not lifting 200-pound cylinders all day, throwing on his back and bitching and moaning, and put the thing together. We got over here some 4-inch cylinders in process. So these will probably be assembled on Monday. I think some of those rods in there are actually for these. So this is the body. Actually, later on, we're going to weld one of these up. We're going to weld the cross tube up. So we've got, let me grab one here so you guys can see it. You got 4-inch IAB. That is a 1/4-inch wall material, so pretty strong. And then we've got these two big number 16 ports. And if you look through there, it's a true number 16. See, I can stick my finger right down in that hole there. That's a 1-inch diameter hole. So fluid's going to be able to come out real easy from both ends. You see that there? A lot of cylinders, you look inside, they'll have a big port and just a small little hole drilled. So we go the extra step, drill them out, gets better flow. These bungs, we actually TIG weld these bungs on to minimize heat distortion in the pipe and ensure, high quality, good penetration weld both ends. And then we're MIG welding this end cap on. You can see a nice flat weld and a big beveled end cap. So that'll last hopefully a lifetime of the cylinder. And then big 1 1/4-inch cross tube at the back of it. And this is a 26-inch stroke version. So we'll make 25 to 30 cylinders a week out of this room here. Over here we have the 5-inch body. So similar construction. Same number 16 ports. True 1-inch hole going through there. Good flow. And then we have TIG welded bungs, all made in-house. You can see there, 5-inch OD, chromed by our friends with Scott Industries out in Ohio. And then we're using a snap ring groove in here to hold the gland in place. So all the machining done right here. These are used on the Pro HD, the Alpha, and the TW5 series of log splitters. Same with the 4-inchers. Now we're coming into the manual machine shop. So we've got a couple of Bridgeports, a couple of lathes. This is our big lathe here. You can see this cylinder. I'll just kind of stand inside it for perspective. This cylinder here is a full 12 feet long, 8 inches in diameter. So it goes all the way back here. And it's all manually machined on this good Hercules lathe here. Picked this up from, it's called Action Machinery in Ohio a few years back. It's been a real good machine. We do a little rebuild work on it. And this goes on our TW10 log splitter, full tree log splitter. Pretty unique capability. Has the number 16 ports on it again. And then 1-inch plate, 18 5/8 grade 8 bolts hold this end flange on. Triple pass MIG weld on this side. And then over on this side, we're getting ready to weld the end cap on. We're just doing a final face, making sure everything's straight after the weld. So this is actually a weld seam in here. And then we're going to face down the back, make sure everything's squared up before we get her on to the next cylinder. This will probably be going in the machine in a couple of weeks, first week in April. I think that's heading down to a dealer in Nashville, Tree Solutions, or Music City Firewood. So that's there. This is the rod for that cylinder on the ground here, beside the old long lathe. You can see 8-inch piston here, wear rings, double seals, big bolt holding that guy on. And then that's actually a hollow tube, so we weld the plug in for weight. We're saving about 500 pounds doing that, allowing us to have a slightly less heavy machine for the old one-ton pickup truck to haul around. But that's a full 12-foot long cylinder there. Pretty nice rod. So that's our manual machine shop. Here on the ground, you're going to see cylinder bodies. This is our holding area, waiting for cylinders to get to the machine shop and get machined. And then we also have some conveyor rollers going on and some other cylindrical parts that are, in process to go in the machine shop. Now we'll come over here. We got temporary manual lathe situated right here. We're actually going to be moving that into this room in the next week or so. And then this is our staging area. Plate seal comes in that door. You can see the various sizes stacked on the ground there. And then this is our kitting zone as well. So this is alpha build. I think there's 7 that we're going to send down to Marathon on Monday. So this is what 7 alphas looks like prior to assembly, with a few parts are to be made. So how it works, the burn table, the machine shop is making parts. I think this Welding has about 128 different parts. They all get collected here, and then they get inventory counted and checked. Once we know we have everything, we pallet wrap this stuff, put it on the box truck, drive it 53 miles south to Marathon where it all gets welded. So you can see some of the structure here. This is a 2x5 tubing for our new axle. Thick walled 1/4-inch wall, very strong. We've got our clevises, full 1-inch thick steel, 1.25-inch pinholes. 2 of those are welded on either side. Our nose piece, which supports our low profile wedge, which allows the box wedge. So that piece and that piece weld into there, and that makes your nose. You got your jacks, 1/4-inch 3x3 for your dual jacks up there. And then you can see this print here. This is our BOM print. So this tells a guy what he needs and how many of them to assemble all this. So it just makes it a little easier. Can't always remember all the parts. So this is, part of the packaging system. We've got our engine trays over here. Those get bent. This is the 1/2-inch plate that the push block actually rides on. So it's full unit. That slot there is where the wedge slides through. That way there's nothing's relying on a weld to hold it all together. It's all one continuous piece. And then that's your alpha build there. And I'll go over here. We got some more 4-inch cylinders. This is our welding area. So we do the vast majority of our welding down in Marathon. However, we're doing our cylinder and some of our smaller parts are getting welded up here. So right here you've got some conveyor rollers, make 300-400 conveyors a year. That means we make about 600-800 rollers a year. That's a 5-inch OD material with solid 1.5-inch rod. You've got drives, so we're machining down that shaft and we're putting this key in for the motor to go directly, and then you have idlers. That's for the bottom, no drives on there, so we don't have to key the shaft. So that's all happening on the ST10, or sometimes on the manual lathe, depending on our machine shop scheduling. And then here, you can see some more finished 4-inch cylinders, and then you can see right here, this is the last step. So we're going to be welding this cross tube on this cylinder, and hell, I might even do it today. I'm feeling a little bit bored. So we're going to take our trusty old Lincoln power wave here, get into full pulse, put a lot of current through it, and get good penetration. Lay a real nice bead across there. We're capping this port here, make sure no splatter gets in or spatter gets into the bunghole, and yeah, that'll finish up and be assembled probably on Monday. So now we're going to head over to the final stop on the tour, and that is the burn and cut room. So this is the biggest room we got in the whole company, and we process 40,000 to 50,000 pounds of steel a week in this room right here. We got this trusty Lone Star Scout burn table. It's about 3 years old for us now, bought down in Texas. Great guys there with Lone Star Cutting Solutions. They've been amazing with service, and tables are real reliable. This table's cut in excess of 1 million pounds of steel in its 3 years, so definitely earned its keep. So right there on our head, a piece of 3/16. No, I lied, that's quarter. This is making trays for alpha. So this piece here is what gets welded onto the alpha right at the block lift. So the blocks, every block rolls right over this solid piece of 1/4-inch steel. We buy stretcher level plate steel, really cool process, kind of innovated by a company down in Pennsylvania called High Steel, and they actually take the coils and they drop them down to a big pit, and then they stretch them. So every 10 feet gets stretched about 1 inch, and that takes all of the residual stress out of the mill. You can see this just got burnt. You look down there and there's very, very few waves and such in it. Without getting stretcher level, if you're doing a tempered pass plate, way, way more bumpy. So that really helps our welders' productivity, helps our stuff be straighter, and then allows us to cut a real close nest. So this 1/4-inch plate, there's not much waste left on it, as you can see. So this table will cut all the way up to 3 inches. Actually, no, I lied there. It cut up to 4 inches. It's a 400 amp Hypertherm with True Hope technology. Hypertherm, New Hampshire-based company. Again, they're real great on service. You know, the 3 years we've had this, you know, obviously we need some parts, and they've been a real good partner in that. So once parts come off the burn table, we hit our cleaning table here. We're just using good old-fashioned elbow grease. A couple of guys standing here with some grinders and cleaning the parts all day. So here's those rings that we're working on over in the machine shop. Gonna take that. I got a magnet right there. Gonna take the slag right off there. We'll hit it with the grinder. Flip it over. And we'll put it here. Done. 2 guys all day doing that. I'll jump in every once in a while. Actually enjoy that kind of work. It's good for you. Get a lot of iron in your lungs. It's a lot of fun. One of these days you probably get a machine and call them time savers to do that, but can't really beat the reliability of 2 guys just working on it. So once the parts come off the grinding table, we go into this rack, and from here we got a couple of guys. Their job is to find the home for the parts. This table here is producing over 2,500 different part numbers in any given month, depending on the builds we're doing. So the 2 guys that take the parts from here, and then they send them down. You can see down in the distance there's the pallet racks. Each weldment, there's 391 different weldments, has a home designated in the computer, and we now break down the parts based off the weldment. So the guys take the parts from here, put them where they need to go. We'll take a look at that in a second. Now we run two saws. They're both hide neck S20s. That's a 1984 and that's a 2020. 1984 saw I've owned that for 6 years now. Bought it off a good friend of mine down in Portland. Been a hell of a saw when you consider the age on it. Cuts for us 40 hours a week. Made up in Ontario. Great company and parts service. Even though that machine's older than I am, they still service it and the parts are still readily available. Hell of a good partner to be with there with hide neck. And on this side, we like that saw so much, we bought a new one a couple years back. I think that's a 2020. Same exact model, a few differences, a little faster computer processors, different frame, but uses 1-inch blades. We buy the blades from Lennox. They're a company that, same company that actually owns DeWalt Power Tools, Milwaukee, all those. I'm pretty sure I'm saying that right. I think it's Stanley, all that. It's Lennox blades, and buy 5-10 blades from them a week. Different materials here. You can see some cylinder materials, solid stock. We've got some 5-inch tubing. So our heavier material sitting on this side. There's some 3x3 we use on the jacks on the Alpha. Then over on this side, we've got some 5x3. That's used on our live decks on our Pro HD. Also our conveyor axles. We got some 1.5 inch, 1045 live deck shaft, pins, a lot of different materials used from there. We buy our stick steel from American Steel, and they've got a warehouse right here in Liverpool. We actually get a truck from them every morning, so we try to keep a minimal inventory on the ground here because it gets kind of messy if you got too many different sticks. So as we work our way down here, we get to the final part of the process. This is the staging area that I discussed earlier. So, got stuff coming off the saws there. And then over here, each weldment has a home. So this center section here is our biggest weldment. It's our Pro HD mainframe. So there's various parts for all the different Pro HD mainframes here. And as they come off the burn table, they go here. When we want to build a Pro HD, which we try to do 2 a week, we come through here with some pallets, and it's kind of like shopping in the grocery store. You have your BOM list, like I showed you guys earlier with the Alpha, and you get all your parts onto the pallet, double check your counts. So you've got your trailer section there, and those parts all live in this area. And then this is your splitter section. So we've broken them down in sections because there's so many parts on this. To put it all in one sheet would be overwhelming for a guy. And so you have your different components for your splitters here. And then you have your trough section right here. You have your different components there. So you can see that's the front plate where the push block goes through. This is the back support made out of 5/8 for our back roller, which sits right there. And then you have the 1/4 inch plates that make these main trough sections there. So we're always filling the inventory, and then we're picking as we want to make the weldments. And over there you have some conveyor sections. You've got our TW2s over there. Let's take a look at those. We've got quite a number of those coming around. So our TW1s, 2s, and 3s, that's our smallest splitter. It's made in batches of 20 or 40 depending on our demand at the moment. And you have the whole section right here. You've got your trays. These are actually tacked together now to be sent down. That's where the logs sit on. You can see the holes right here for the manual block lifts. And then over here, this is the main splitter beam. It gets welded on top of the 2x5 1/4 inch. That's a solid 1/2 inch steel, super strong right there. And then you've got your 1.5 inch tubing that holds your valve stand. And that's welded right up to here. Then we've got our 1-inch step wedge. This is also made out of AR400, comes off that machine I showed you guys earlier. Double beveled there. It's got the step down here, so what that lets it, as the log starts, it starts to split at the bottom, gets a good crack, and then it finishes splitting up here. And that's a solid, or a full 12 inches tall. That gets welded right to the top of this 1/2 inch plate. And underneath that 1/2 inch plate, we got a 2x5 1/4 inch wall tube. And that really provides a strong structure for this TW2. So, there's the drawing for that with all the parts that you guys can see. And then on the shelf over here, we have some of the smaller weldments, so like the accessories and the options that go on the different machines. So here, this is our back roller on our Pro HD. You can see this is the 5-inch pipe, same pipe we use for the conveyor rollers. We also have some drops, so it's nice to have this short little piece to be able to not throw that last 20-30 inches out. Solid, that's an 1.5 inch 1045 shaft. And then we have 1/4 inch plate, that's the outside of the wheel. And then we have 1/4 inch plates the inside of the wheel. That welds to there, this welds to there. And then we have our 3/8 thick teeth. Well, let's just look here at the drawing. I don't have a drawing. I think there's 34 of these per roller. And these are burnt on the burn table and they grip the log real nice. That supports the back of the log as it's going through. Let's see what other cool parts we have here. Here's our table grates. Goes on the end of the Alpha. You got 1/4 inch paneling on the side. You can see the angle there, and then the 1x1 tube sticks in those holes. Here's more table grates here. 1/2 inch on the bolt frame, so this one bolts to the Alpha. And then this is the gusset 1/4 inch that's on the outside, so 1/2 inch, 1/4 inch, and then there's 18 30-inch long pipes. Gives you a lot of area for cleaning out that debris. So looks like we're ready to ship a few of those down. Here's some 2x5s for, looks like a TW10 trailer frame right there, so that's getting ready to go. And then you can see these are other pallets that are getting staged, ready to go. And then that's the overhead door. Box truck backs up to there, and twice a day, 10,000 pounds maximum potential heads down to Marathon. And that, in a nutshell, is a Syracuse machine shop. Yeah, one of the more complicated things we do, try and keep all these parts flowing good. 3,000 plus different part numbers a week, 40 to 50,000 pounds of steel, going through multiple processes. Some of it's hitting the burn table and 2 machines and a welder before it gets out the door. So that's how we make log splitters here at Timberwolf. Thanks.